right, hello everyone. Hello, I hope everybody is having fun at this last day of this user conference. Getting ready for the party, slowly. I really appreciate that you're here. Let me introduce myself. My name is Miriam Schmitz. I'm an instructor and tech lead at Esri Educational Services. So that's what we're basically teaching classes there. We're developing a lot of course materials to teach ArcGIS to you. And, we deliver them in the classroom online. So today, Nicholas Ginner joins me here. I'm based actually in the Redlands office, and Nick is from the Washington, D.C. office. Nick, do you quickly want to say something?
Thanks. My name is Nick Ginner. I work in Esri's Washington, D.C. office. I was an instructor for a little bit of time, and I just moved into a tech lead role as well. So we're happy to be here to talk about imagery this afternoon.
All right. Appreciate you being here. All right. So we have a full schedule. So let's get started right away. Let's get started thinking about imagery. Now, how many of you use imagery on a regular basis? Can you give me a show of hands? Looks like most of you do. I want to remind everyone, this is a very beginner level presentation, so bear with me in the beginning. Don't walk away right away. We will start from the beginning. We will actually start with a few imagery basics and then go into more detailed topics. But no matter what, it's always good to keep in mind why we're doing all this. We all know that, right? Imagery, it is visible intelligence. And if we look at these pictures, like this one here from 1969, when the first images were transmitted back to the Earth from the moon, this first iconic photo of the entire Earth gave us a whole new perspective to our planet. Or this one then a bit later in 72, when Apollo 7 took the first photo, the full photo of the entire Earth, the blue marble. It's still fascinating to me how this really expands our perspective. Well, we see in imagery what's visible to our human eye, but we can see beyond that, right? We can see into different parts of the electromagnetic spectrum. We can take a peek into the past. We can actually compare imagery from different times. So this is all, part of what we want to keep in mind here. All right, so after a few basics, I will talk about sources of imagery. I will talk about platforms, sensors, and then see what we have available in the Living Atlas. And later on, we will also look at other imagery sources, into internet sources, and also into Lidar sources. Imagery usage, we need to understand about different forms of image storage first, and then look into image processing, how we can actually make that imagery usable for the use in ArcGIS before we go into the analysis. The last part will be all covered by Nick. He will talk about Lidar data, how that ties into the imagery realm, how we can visualize Lidar data, acquire Lidar data, and analyze Lidar data, right? So without losing too much time, because there's lots of exciting stuff to come, I want to cover some basics here, just to remind everyone what we're talking about. Rows and columns of cells, that's what makes a raster in ArcGIS. And when we're specifically talking about imagery, we're calling these cells pixels, picture elements, right? They have a certain cell size, that's the raster resolution. They have a spatial reference. Usually the lower left corner stores one single XY coordinate, which basically is the basis for the spatial reference of all other cells or pixels in that image. And this way, imagery, like any other GIS layer, is georeferenced and overlays with existing vector layers and raster layers as well. In terms of spectral bands, you might have heard this term many times before, but do we really understand what it means? A spectral band. You see, it says here on the slide, well, it's basically a range of wavelengths of the electromagnetic spectrum. We all know the sun emits many more wavelengths of the electromagnetic spectrum than what we can see, right? For example, ultraviolet, that damages our skin, the infrared, the near infrared. All of these wavelength ranges are actually covered by different portions of a sensor. So you can imagine it in a way that a sensor has different channels that are each sensitive to a certain wavelength range of the electromagnetic spectrum. And that's what we really mean when we talk about spectral bands. You see in the graphic here, we do have the red, green, and blue, the visible light, that is maybe covered by one band, but then we might have a near-infrared band, an infrared band on the one side, and gamma, X-ray, different wavelength ranges basically. And based on that knowledge, well, when we apply it to imagery, we have single band imagery, where an image is basically just made up of one single wavelength range. For example, if you think about it, a black and white photo would be like that. Or if we're getting away a little bit from the reflected sunlight and think about imagery also as digital elevation models, they are typically one band. But in imagery, where we represent the reflected light of the sun, typically we have multiple bands, multispectral imagery, multiple bands that represent, for example, the near infrared and infrared, the thermal infrared, UV, different bands that are overlaid on top of one another and give us different types of information. All right, so just some examples here. I mentioned the grayscale imagery. I mentioned the DEMs, the digital elevation models that make single band imagery. And when it comes to derivatives from these DEMs, you might have heard these terms before. We can derive from that 3D imagery. If we have an digital elevation model, we can derive what's called a digital terrain model, which basically, represents the bare earth in 3D, and a digital surface model, which, represents the surface of the earth, which is not necessarily just bare earth, right? It's trees, it's buildings, it's whatever makes the surface of the earth where the light bounces back from. And we want to keep that in mind because these terms, they are floating around everywhere. In terms of multispectral imagery, we have the vast amount of natural color imagery, like aerial photography, that most of you guys probably have used before. Imagery that serves as a great background, for example, for your digitizing, for your mapping, for whatever you're doing in ArcGIS. But then we can do so much more with multispectral imagery. We can extract information. We can combine different bands with one another. We can symbolize based on different bands. And for example, to see it in the center here, where the red vegetation really pops out. That's a false color or color infrared image where we take the near infrared and assign it to the red channel so that we can visualize healthy vegetation very well. We will come back to that idea in a little bit later. Or, for example, calculate NDVI, the normalized difference in vegetation index from this multi-band image, from this multispectral image, where we basically subtract the near-infrared, the red from the near-infrared, divided by the sum of the two, and this way create an index of greenness of the vegetation. Symbolize healthy vegetation in the image right away so we can analyze that. So there are many, many different ways how we can use these different bands in imagery to, to extract and analyze information. All right, so let's talk about imagery sources. There are all these different sensor platforms out there that can carry the actual devices that are used to capture imagery. And you see quite a few examples here. Everybody knows about satellite imagery, probably, right? We have Landsat up there. We have MODIS up there. We have the European sensors up there. So satellite imagery can be geostationary, can be basically following the rotation of the Earth, or it can actually cover different parts of the world. Then aircraft, aerial photography, very, very common. How many of you work for local governments who usually fly their imagery, right? So you probably know what I'm talking about. Aircraft, helicopters. And then the newest kid on the block is the fun stuff, the drones, right? How many of you have experience with flying drones? Just out of curiosity. Oh, yeah.
I think there was one flying around outside of this building yesterday.
Oh, my gosh, yeah. I want to have one. Makes you want to play with it. All right, yeah, drone imagery is very cost effective, right? We can fly it immediately, say there's a natural disaster, there's something that we need to access quickly. We don't want to wait for, days, weeks, months for the imagery. We can assess the condition of the Earth right away. And then not to forget ground-based imagery. Oblique imagery that could be captured from cars or from handheld sensors. This is also a type of imagery that we don't want to forget about. All right, so based on these different platforms, well, we do have different sensors. You see them listed on the slide here and pretty much divided up into passive and active sensors. And if you think about it, it makes sense. Passive sensors are the ones that simply record what's reflected back off the sunlight that hits the Earth. So, for example, a camera is probably the simplest sensor we can think of, or a spectrometer that basically records all the different wavelengths that are bounced back, say, from the vegetation canopy, or from the ground, or from whatever you hold your spectrometer over. Versus the active sensors that are actively emitting a light source, not necessarily light source, but like a laser source with Lidar or radar or sonar. So these are the sensors that basically emit energy and reflect and record what's reflected back. All right, so let's pause a moment and take any questions that are immediately in your head. I will make sure we have some short time at the end, but just quickly, yes? The question is, what's the difference between a DEM, and a DTM? I had it on the slide. I can show you after class, maybe later. the DTM shows the elevation in 3D, basically, or allows you to store the elevation in 3D. Okay? Anything else? All right. Well, then let's briefly take a look at some imagery sources. I want to take you to the Living Atlas here. I want to take you to the ArcGIS online site that basically hosts the Esri curated imagery. And note that I say curated here, it's not Esri imagery, it is actually imagery that belongs to many different parties. It's simply Esri that hosts this imagery. So I'm logged in here to an ArcGIS online organization. It could be any organization. And I'm going to the gallery. One thing to keep in mind is to go to the Esri featured content. It also always wants to go first to the organization's content. But once you're in here, you're in the Living Atlas. It's the data, the imagery data in particular, that comes with the software. So you see there's actually quite a bit in here. So let's go to the imagery section. And well, we're probably all familiar with the base map imagery, but check it out anyway, because there's much more available in terms of background imagery than in the actual drop-down for the base maps. When you go to ArcGIS Pro, ArcMap, or ArcGIS Online, there's, for example, things like MDA Natural View, Dynamic Image Service. There are many, many different backgrounds that you might be able to use for your own maps. I think the World Imagery Firefly map was in the plenary on Monday. So check that out. And then there's a whole section of multispectral imagery. We know what that is right now, right? We know that it's imagery that consists of multiple bands. And this is typically satellite imagery here. You see that we host actually the entire series of Landsat imagery here, Landsat 8. To get an overview, there's actually, if I don't even have to search for it, it's right here. Landsat Layers gives you a nice overview of all the different imagery from the different years that is available here in this image service. How many of you have used Landsat imagery before? Few of you, okay. Maybe just to give you a little bit of background, it's really the longest standing satellite imagery acquisition program that we have. It started back in the 70s with Landsat 1 and all the way up to now, Landsat 8. It's a collaboration between NASA and the USGS and maybe a few others that I don't recall right now. But anyway, we have all this wealth of imagery over time, which of course makes it great for change detection, right? Because we have that record. And it's multi-band imagery. Let me go back here and show you the details of this. It comes at a 30-meter resolution. And we also have derived products from this imagery. If you read the description here, oops, didn't mean to go to this one here. I mean to go to the Landsat products. There we go. You see that we have the different years listed here. It gives you all the different bands that are available, and lots of stuff to read up on here. In terms of derived products, there's, for example, vegetation products, NDVI products available, raster products, moisture indices, lots of good stuff. So climate change research, stuff like that. Okay, and then not to forget there are other multispectral sensors as well. So for example, MODIS is another platform that you might want to check out. Different band combinations. worldwide imagery. All of this is worldwide, so I don't know if we have any international visitors here in the room, but for each country in the world, really, we have the imagery available here. All right, there is a question in the back of the room. Yes?
So I see that there's a tab there that says Open in ArcMap.
Yes.
I'm wondering is there ways that you can actually download onto your system data sets, or they just come up Arc Online, or if you did analysis using one of those and had an output raster,
Right.
is there a way that you can actually get this info?
The question is, how do we download the imagery? You have seen the Open in ArcMap tab, which will basically pull the imagery into your ArcMap document. We will get to that in just a little bit. Just a brief answer here. These are image services that you can use in the same way as any local imagery. Depending on how an image service is set up, you can either download or not. I don't think these are set up for download, actually, but you don't need to. You can use an image service in geoprocessing tools and raster functions. In any, way you can use local imagery. So there's really no need to download that imagery.
My last question was, if you processed using one of these imagery sources, and you had a raster output come out of your GP tools,
Right.
that output you saved on your system?
The question is, if you use an image service in a geoprocessing tool that creates an output, yes, the output will be stored then on your local system. Yeah. Okay? Thank you. Great question. Right. Which is basically the perfect transition into my next slide. I don't want to go back there, though, without showing you very, very briefly here the temporal imagery products that are available for change detection, right? So, for example, seasonal changes based on NASA's imagery, Landsat time-enabled imagery. So all these are image services that you can basically use with your vector data. All right, so back to the slides. We had the question about the, ability to download, and I answered very, very quickly, these are image services, without really explaining yet what is an image service. An image service is basically imagery published to the web, and here's the trick. What's actually delivered to the client application, in this case my web browser that connects to the imagery, or in another case maybe my ArcMap or ArcGIS Pro that accesses the imagery, what's sent back to the client are the actual pixel values. And that makes an image service different from a cached map service, for example, or a feature service. A feature service, we're streaming points, lines, and polygons. In a cached map service, we're streaming pictures of the data, pictures maybe of imagery. But in an image service, we're actually streaming the pixels to the client. And that's why you can use this imagery in GP tools, in, say, an image classification or whatever you're doing with it, right? We can actually process the imagery in the same way. Image services can also be cached. We get the best of both worlds. We can make cached requests to an image service if we want to just use it for background. But we can also make dynamic requests to an image service. Even if it's cached, it's smart enough to recognize that dynamic request if, for example, a geoprocessing tool wants to analyze the pixels. Comes with metadata, and as I said, the ability to upload, download, it's a configuration in the image service. So image service is one way to store and distribute imagery. But what about local storage? Of course. We do need the ability to store large amounts of imagery also locally in the geodatabase, preferably with the rest of with our other data. And this is where the Mosaic Data Set comes into play. The Mosaic Data Set is an item in the geodatabase for storing large amounts of imagery. That's what it's been designed for. And again, there's a trick to it. The imagery itself will not be duplicated. It will be referenced by the Mosaic data set. The imagery itself stays in its native format. And, well, we can add imagery from many different formats to the same Mosaic data set. What the Mosaic data set will do, it will dynamically mosaic that imagery together and display it as one seamless image. We can apply functions to it. We can actually set up rules, what's displayed on top, maybe the newest imagery or the newest cloud-free image, whatever it is, what we want to see. But we're not duplicating the imagery. And if you think about it with, terabytes and terabytes of imagery data, that's not really practical, right? So that's why we came up with this Mosaic data set. And later on, Nick will actually show us more about Mosaic data sets and what else we can do and put into a Mosaic data set, right? All right, so Mosaic data sets, check it out. It's not hard to create. It's a right click on the geodatabase. Here we see on the slide how it looks. It's a container for your imagery designed for storing large amounts of data. And we can mix and match multiple image formats, source formats, multiple resolution, multiple years. I mean, you name it. And to give you the big picture, in all likelihood, we will probably, for our imagery workflows, use a combination of Mosaic data sets and image services. Imagery that is captured, say, by satellites or aerial photography, whatever the source is, or drones. First of all, well, we need to process that imagery and store it locally, preferably in a Mosaic data set. That's what we see here on the left side of the slide. But then to distribute that imagery within our organization or maybe even outside to clients, to collaborators, we might want to go ahead and publish that imagery as an image service. And I should say, to do that, to publish an image service yourself, you do need ArcGIS Enterprise with the imagery role, with this new imagery role that we have there. All right, so moving on here to some imagery usage. What do you guys use imagery for? What is this? Some common imagery uses. Throw it out there. Yeah. Excuse me? Facility design, right? We use it as ground truthing, maybe for facility design, visual inspection of what's there, background, of course, to our vector data. Anything else? Habitat changes over time, right? Change detection. How does it change? How can we use the change to explain maybe some other phenomena? Analysis, yeah. And here you see on the slide some other typical image analysis uses, like land cover classification. We can also compare that over time. Suitability analysis, extract different criteria from imagery and find the best suitable location, maybe for a, say, species habitat or whatever it is we're trying to resolve. Visibility analysis, hydrological analysis. So lots and lots of different applications for image analysis. In forestry, in engineering, if you think about it, we want to know about the terrain of a new site. In natural disaster management, we want to see the before and after. So many different uses. So that's why we at Esri have also decided, well, over the last years, we have to do more in terms of imagery. And we're really working hard on making the ArcGIS platform also an imagery platform for image processing and image analysis. So you will see over time, more and more of these tools are coming out, and you might be surprised. We're showing you some of them. There's actually quite a bit of it already there. And speaking of image processing and analysis, well, how do we traditionally analyze imagery? Has anybody done some image analysis in ArcMap before? No? Anybody? Yeah? Maybe have you used the Spatial Analyst extension before, right? And maybe ran some geoprocessing tools? Yep, the lady is nodding. Thank you. Geoprocessing tools is how we traditionally process imagery, right? But if you think about it, with larger and larger amounts of imagery, geoprocessing tools create outputs on disk. We're duplicating that imagery every time we run a tool. And that becomes more and more impractical. So raster functions come to the rescue here. They apply an algorithm on the fly to the imagery and just create a new layer in the table of contents. So we're not duplicating the imagery anymore, and they can do a lot. You will see they can actually transform the data in a similar way as geoprocessing tools can do. And I just want to quickly show you some of the raster functions and geoprocessing tools that we have available. In ArcMap and ArcGIS Pro, raster functions are not unique to ArcGIS Pro, but much more accessible, I must say, and easier to use. So I would really recommend that you check out the imagery section here, the imagery tab on the ribbon in ArcGIS Pro. It makes it really easy to use raster functions. And let me just show you, like, on a quick example here. I have an aerial photo here of a neighborhood. It's actually a 4-band image. If we go to the properties, we see in the source tab, we have actually 4 bands, a near infrared band as well, which makes it suitable for image analysis and vegetation analysis, NDVI, but also for image classification. That's another image processing and analysis that we can do here. And let me show you a quick image classification workflow. Now, I will start out with a raster function because for image classification, we want to display the raster with the best amount of contrast that we can achieve visually between the classes already. And I want to show you that at an example of a raster function. So I'm selecting my image and go to the raster functions here. You see we have different analysis functions, classification and segmentation functions, math functions, surface functions. So a lot of the geoprocessing tools are nowadays also available as raster functions. So the first function I want to find is the extract bands. I can, from that 4-band raster, I actually want to extract 3 of them to start my classification. Now I will need band 4. I will need the 4, 1, and 3 combination. All right. And just to make sure I'm not making a mistake, you see at the bottom, actually I have a choice now. I can apply that function to the selected layer or create a new layer in the contents pane here. But I'm not creating any new data on disk with that new band combination. I'm simply applying the function on the fly when I create a new layer. See, band 4, the near-infrared band, is now the red band. That's why all the green vegetation that reflects heavily in the near-infrared is bright red in the image. Green channel takes band 1, blue channel takes band 3. Okay, I have a 4-band image layer now that I can feed into the classification. I should say a few words about raster functions. They are applied to the visible pixels on screen on the fly. So really, it's a good practice before you apply a raster function to actually zoom to raster resolution. And you see now we can avoid any artifacts here. We can actually zoom and pan, and you might notice a slight delay there. That's when the software applies the raster function to the new extent. All right, so based on that, let's do a quick segmentation here. And for our classification, we want to segment the raster first, group similar pixels together. So segment mean shift, another of these tools that is available as a raster function and as a geoprocessing tool, only that it would take about 15 minutes to run the geoprocessing tool, and I want to do this quickly, so I'm applying the parameters here just to the visible pixels and create a new layer. And you see we get actually the segmented image just for the visible extent. To complete the workflow, I have prepared the layers because I know Nick is getting antsy there. I will finish in just 1 minute. I've actually created the segmented image also with a geoprocessing tool and created a physical TIFF image on disk. So once this decides to display, I will show you that. Let's zoom to the layer. There we go. So the segmented image is the basics for object-oriented classification that we can do in the software. Object-oriented classification basically uses groups of pixels, segments, and not only the spectral characteristics of those segments, but also the shape and size of those segments to classify the image. In this case, it is a type of supervised classification where it actually uses a training sample. In this case, we're actually classifying different land use classes, so we can actually, create that classified image by running a train support vector machine geoprocessing tool, which creates an ECD file, Esri classifier definition file, which will then be fed into the classify raster tool. I'm not going over the workflow, I'm just showing you some results here. This is a typical image analysis that we can do, land use classification here. And even to take that a step further, we could reclassify those land use classes. Here what we have, gray roofs, bare earth, grass, water. We could reclassify that into pervious and impervious surfaces. That's maybe interesting for taxation purposes or conservation purposes. So that would be the final result then. Okay? So just as examples here of what we can do with image analysis in ArcGIS Pro. Okay? And with that being said, I'm turning it over to Nick, who will talk about Lidar sources.
Okay, thanks, Miriam. So yes, in the interest of kind of keeping the conversation going, remember this is all about imagery and perhaps the products that we can derive from imagery, right? And so I'm going to kind of switch gears a little bit into talking about Lidar. So anybody work with Lidar? Lidar point clouds? A couple people have? Okay, so first thing we'll do is kind of a short review, and then basically several of my demos will be building upon some of the conceptual things that Miriam talked about. So we'll get in and we'll build some digital elevation models and digital surface models, use a couple of geoprocessing tools with Lidar, and go back to the concept of the Mosaic Data Set. So just a little bit background on Lidar. Basically, Lidar stands for light detection and ranging. So if you kind of look at the picture there on the slide, it is one of the active sensors that Miriam spoke about. So in this case, it's airborne Lidar. You kind of have a plane that's sending a signal to Earth, and that signal is recording elevation and a few other attributes every single place that it hits. And what this creates is not a raster of cells, it creates a cloud of points, okay? And so these points, well, I should say Lidar originated, it's been around for a while back in the 60s. It's been supported in the software for a couple of versions, but I think there's some really cool things in terms of visualization that you could do with it in Pro. So when it comes to types of point clouds, probably the most common one that you'll find is airborne scanned Lidar. So this is going to be Lidar collected from a plane, but you also have applications. One of the newer ones out there is called airborne Geiger mode Lidar. If you get a chance, the company or one of the companies that's working on this is one called Harris. And if you get a chance at the Expo Center, they would probably be the best people to talk to about this. Also, Lidar can be collected on mobile and tripods and drones, right? So we have an application called Drone to Map, where basically that's out there. It's taking photographs as it's flying around. It's perhaps grabbing sort of oblique photographs as well, but it's also taking and recording elevation measurements. So many different ways to collect these Lidar point clouds. Most common one, probably the airborne scanned. So what kind of attributes does Lidar collect? So obviously it's GIS, so we're grabbing the XY coordinates, spatial location, but it's also grabbing the Z coordinates, which are the vertical, right, the elevation values. Within the points, the attributes are also, or can be, intensity, so kind of recording the strength of the signal, the return number. So essentially there are several different types of returns. When I kind of talk a little bit about creating products from Lidar, it's important to know about the returns because there are something called ground returns, which is basically recording all the ground, sort of that bare earth observation, versus something like a first return, which is bouncing off of trees and buildings, right? So we'll use returns and filter by returns to create some different types of surfaces. Lidar can also have different classifications, so categorical classifications, and it's not kind of, I guess we would refer to it as sort of universal across all Lidar data sets, but there are some more robust Lidar data sets that perhaps have classification codes for buildings or trees or power lines or impervious surfaces. Others, perhaps due to the technology at the time they were recorded or the budget of the organization that's acquiring the Lidar, is only going to have maybe a few class codes. Maybe it's just going to be ground and non-ground, right? So there's different kind of levels of robustness, so to speak. Some Lidar data sets can also be collected with RGB values, red, green, and blue. So Miriam talked about the visible part of the spectrum. That's what we as humans see. We see the visible part, and every color that we see is red, green, and blue values. So some Lidar sensors also collect red, green, and blue, which is kind of nice because you can actually see the colors of a building, the colors of a tree as you view it in 3D. When it comes to Lidar, the kind of default data structure for working with Lidar, the one that you'll probably see most common, is this thing called the LAS data. LAS, it's an industry standard file format that's been developed by the ASPRS, American Society for Photogrammetric Engineering and Photogrammetry and Remote Sensing. So LAS files and a sort of derivative called a ZLAS file can be used now individually in ArcGIS Pro, but I'm going to show you how to put them into this thing called the LAS Data Set, which allows for more capability. So a little bit of background on Lidar. So what's this thing called the LAS Data Set? It's very similar in concept to what Miriam talked about with the Mosaic Data Set, where it's this kind of container for storing data that you're just referencing that data back on disk. And so the last data set is essentially a container for storing or referencing many LAS or ZLAS files that are stored on disk. So it basically just points to them. It's very quick to create. It's relatively small in file size. And once you create one, it's easy to just, well, let's say we had 20 LAS files. We kind of have this nice coverage. We went out and acquired more. It's very easy to pop those back into your LAS data set already, that already exists. It allows for really quick display of these point clouds. And so not only can you then visualize them, let's say you want to visualize just the elevation values, you can dynamically and very quickly filter out, well, let me just see the ground points, or let me just see the first returns, or let me only see buildings, or so on and so forth. Additionally, it's very easy to create a dynamic kind of representation of the point cloud. You can create dynamic triangular irregular networks, so TINs, either in 2D or in 3D. And we'll take a quick look at that in a second. The last data set's great for QA, QC of your LiDAR coverage. It kind of puts it into sort of what looks like a layer of footprints, sort of evenly sized tiles. And you could kind of go in and you could take a look at, well, is this area sampled more densely? Are we missing values here? Do we potentially have outlier values? Nice thing about the last data set, again, something that I'll show you, is you can generate products from the last data set, right? So you have point clouds. It's very easy to generate digital elevation model rasters, DSMs, which are digital surface models, TINs. So a lot of this kind of going from one data type to another for additional use, maybe analysis and so forth, right? This is all about generating products from the imagery sources. Additionally, there's some functionality in here or in Pro to deal with really large LAS files and to kind of tile them up for more sort of useful storage. So what does it look like? Let's say I have a bunch of LAS files. I put them into a LAS data set. A LAS data set has the LASD file extension, and it creates for you this sort of footprint where at a certain scale, when you zoom in, you actually start to see the points. So we're going to focus pretty much on ArcGIS Pro here, but it is important to know that, and some of you might be working in ArcMap, so if you're working with LiDAR data in ArcMap, there is a toolbar called the Last Dataset toolbar, and it has functionality to go in and, for example, symbolize by points. And when I say by points, symbolize by their elevation attribute, or the RGB attributes if you have them, or the class code, or the intensity. As I mentioned, you also have the ability to symbolize by surface. So with a quick click of a button, let me see the elevation surface. Let me see a slope. Let me see an aspect. This is an example of that same area, slope. You can also filter out by return. So in this case, this is along the Pacific Coast Highway, just south of in Big Sur, California. And basically what I've done here is just filter out the water, any LiDAR point that has touched water, so you can kind of filter it. Nice thing about working with the LAS toolbar is that you have this thing called the point profile. So this is actually kind of a 3D side profile of the Bixby Bridge in Big Sur. And in ArcMap, you can also use the 3D viewer, which gives you that kind of 3D representation. But a little bit about ArcMap, pretty much all this you could do in Pro as well. One thing that I do want to point you guys to, and I'm happy to share this link with you afterwards, there are a number of geoprocessing tools that ship out of the box with ArcMap or Pro for working with LiDAR data. There's also an additional toolbox that's been developed by the 3D team that doesn't ship with the software, but they still share it out, right? So it takes a lot of testing and a lot of work to get tools to actually be in the shipped release of the software, but you can also build your own tools. So this is an additional toolbox that does a couple of additional cool things that you could download and just add it into ArcMap. This currently is only available for ArcMap. I'll share with you guys the link afterwards. All right, when it comes to working in Pro, I'm sure that most of you have seen quite a few sort of presentations and demonstrations in Pro. Thus far, you could work with when working with LiDAR in Pro, we're obviously going to be using the ribbon. So you'll note that on the Appearance tab, you have the ability to do that same kind of point symbology, how you display the point cloud. You can do the filtering from the appearance tab. There are several geoprocessing tools that will ingest LiDAR data, LiDAR point clouds as they are. So rather than creating the raster first, you can use several geoprocessing tools to do things like locating outlier points in the point cloud, doing line of sight, contours, and aspects, and other types of surface type analysis. And additionally, you have the ability to go in and to edit and perhaps reclassify your point cloud. So let's say you have a point cloud and it's in a city and you're kind of looking at it in 3D and you're noticing that there's a bunch of points kind of floating up somewhere in the stratosphere and they're called trees, but you know that they're probably just erroneous or noise, right? So you can go in and say, no, this is not actually a tree, this is not actually ground, this is just noise. So you can kind of reclassify your last data. Before we do any kind of quick demo on the LiDAR, I do want to show you a good location for finding LiDAR data. This is the USGS Earth Explorer. This I find to be an excellent source for raster data in general. So not only LiDAR, but things like, well, let's see here. We had a question about Landsat earlier. So here, you can go back and download Landsat 1 multispectral scanner data all the way back to 1972. So it's not just for LiDAR, it's quite a bit of other raster data like elevation, imagery, and so on and so forth. All you need to do for the USGS Earth Explorer is create a login. It's free, you can download as much of it as you want, you can download it in bulk, etc. So let's just take a quick look at LiDAR. So I'm going to pop under elevation here. We'll take a look at the LiDAR option, and I'm going to click this little map here. And what it should do is give me a visual of the coverage of LiDAR in the US. So as you can see, you kind of have these grayish, or not gray, sort of purple, reddish polygons that show you the coverage for parts of the US. So not every place is covered. There's certainly more coverage in some places, but it'll give you a nice picture of what's available out there. So the process for doing this, let's say I want some LiDAR data in Monterey, California. We'll go in, we'll click a predefined area. So I'm going to click here to add a shape. I'll choose a state, so we'll choose California. I could sort of then, aside from California, search throughout the whole state or different kind of standard geography. So maybe we'll do a county. And I know that I want to search for LiDAR data in Monterey County. Okay, so we'll do this. We'll click add. So immediately you're now going to get this kind of reddish polygon that says, hey, we have some stuff here. All right, next thing we'll do is take a look at the data sets. Of course, we're searching for LiDAR. And then I can go in and click results. So now what we're doing is searching this website for the availability of the LiDAR in that area. Now, one thing that's really nice about it, let's say you don't want to download 2,000 tiles, you just want to get a couple for a particular area. You can actually go in and export out a shapefile of the footprint, right? So you can generate this shapefile that gives you, well, I know that I want 2 tiles for this particular area. You'll actually get the names of those tiles such that you can go in and download those particular ones. So it's a quick export. You'll get an email. You can download the shapefile, unzip it, and bring it directly into Pro, which is what we're looking at right here. So these are all the LiDAR tiles for that particular area that I searched in Monterey, California. So we have a particular one that we want to go back to, and we'll go back to the Bixby Bridge. So let's go to a bookmark. And all I really need to do then is grab this particular bit of information. So maybe we'll click on this tile. I'll simply copy the ID. We'll head back to the USGS. Now in this case, I'm going to click on additional criteria, copy and paste that value in. We'll click results. And now I'm able to go in and download this particular file right away. So I know that that's the tile that I want. So if I were to click on the download, it'll ask me, do you want an ALAS, an LAZ, or the XML? I'm going to say download the last product. So then the result of this, if we go back to Pro, looks like this right here. Get this out of the way. Lots of too many folders here. All right, so we're in here. And on disk, this is what we're looking at right here, the last file. That was 407. So the next thing I'm going to do is pull up a geoprocessing tool, and we'll create a last data set to put that into. So we'll do create last data set, click this. My input files, I'm simply going to pick the last file that I just showed you that we just downloaded. So here's our last file, and again, you could do multiple ones. Create an output last data set, so we'll just call this our test last. Okay, we could choose a coordinate system, and we might decide that we want to compute statistics. This basically will, if you have multiple last files, it'll compute all the statistics. What's the average RGB values? What are the average intensities, and so forth. And we would simply click to run. So this is now added in the last data set. And what I'll do is turn off my footprints. We'll take a look at the last data set. There's the footprint. And as we zoom in, we'll start to see that point cloud appear. All right, and so we could click on individual points in the point cloud. And of course, if we click on those, here are your attributes. Right? So remember, we have X, we have Y, we have Z, we have class codes, returns, intensities, even the time that it was recorded by the sensor. So these are some of the main attributes of a last data set. Let's do one more quick thing before we flip over to the Mosaic data set. 3D is pretty cool. We know we have elevation data. So let's head up to the View tab, and we'll click Convert. And now we're converting the 2D map into a 3D scene. So immediately what you'll see on the left side is the last data set is going to automatically be added in as a 3D layer. And now, because we're in Pro, we could do 3D and 2D side by side. Now we're actually seeing a 3D representation of that same place. And the point cloud is loading in and drawing in. All right, so that's kind of a little bit of a background of the Lidar and the last data set. All right, so let's move on. We'll go back to the slides here. Next thing quickly that I want to show you is working with Lidar in a Mosaic data set. So Miriam mentioned that the Mosaic data set is a way to take lots of rasters and say they're all stored in a folder, or I guess, well, in a geodatabase, all these rasters. We build the Mosaic data set, and we're not replicating it, but we want to look at a lot of rasters together. So this is going to prevent having, say, 100 rasters in the contents, just pointing to them on disk. We could put Lidar in a Mosaic data set, and why these are advantageous is that you could run those raster functions on the Mosaic data set. So it's Lidar, it's a lot of Lidar, it's now in a Mosaic data set, and we're now going to be able to, say, generate, well, image products like an NDVI or classification, or say surface products like a viewshed or contour on lots of Lidar data, and we actually we haven't even made any rasters yet. You can use it as DEM, you can use it for orthorectification, you can use it in other applications that support rasters but not the last files or last data sets. So again, we start off with raw last files, we put them into a last data set, and from the last data set, by throwing a couple of filters on the Lidar data, we can automatically create a mosaic, say a DEM, and a DSM, the surface model, which will allow us to generate even more useful products. So let's take a quick look at this. And we're going to head to a place, it's very near and dear to my heart, a place called Worcester, Massachusetts. And we're just looking at kind of a suburban area. So what I've done is created one Mosaic data set, and this is just a simple digital elevation model. Right? So the Mosaic data set's here. Here's our lowest value. Here's our highest value. These are in meters. This is simply sea level measurements. Let's go back to our analysis here, and we're going to create a Mosaic data set. So we create a Mosaic data set, specify an output location. It's going to be in a geodatabase. So we'll call this our test Mosaic and say OK. Oops. I'm sorry. Output location first, the geodatabase, then the Mosaic data set name. Call it we used to call it WooTown, so we'll call it that. Coordinate system, we're going to want to specify that, so we'll use the current one. And I'm not going to really worry about any of these other parameters right now. This is just a container for storing the last data sets. So we'll run this to create the Mosaic data set. Okay, so we're good there. Now we need to add the Lidar into it. So we'll pull up another tool here, and we're going to choose to add rasters to Mosaic data set. Now what's nice about this is that you actually can say, well, I'm working with a certain type of imagery from a certain type of sensor. I'm working with Lidar data. I'm working with different types of data, and I'll show you that. So we'll pick our Mosaic Data Set. Under raster type here, let's say that you are working with data from the Landsat 8 sensor. These tools are basically have intelligence built into them to kind of set parameters and defaults based on what you might be working with. So I know I'm working with a last data set. Last data set. And now if I check this little button right here under the properties and go under the last data set options, I'm going to be taking a point cloud and creating a raster, so I need to set up a pixel size for my cells. I'm going to be using elevation, and watch this, a predefined filter. It's so common that folks create digital elevation models, digital surface models from Lidar data that they build a drop-down in for it. So for the DSM, when I click on the filters, what is automatically happening here is it's saying, take all of your Lidar point cloud, but only give me the first returns, the first thing that the sensor hits. That's the surface, right? Remember, a DEM is essentially the ground. A DSM is the building heights and the trees and the people and the cars and whatever else is actually on the ground. So this is immediately filtering out that surface, only the surface. So let's see what else we have here. We want the filter, see about output properties. We'll choose just a sort of method that allows us to, for some interpolation if we need it, and we'll say OK. Now I'm not actually going to run this because it takes a couple of seconds, but essentially what this will now do is create for us the digital surface model. So if we look at this, now you can actually see those buildings and those trees and those individual houses. So the thought here then is to take the NDSM, the surface model, and subtract from it the digital elevation model. Tops of buildings, tops of trees, minus the ground gives us a 0 value for the ground and the height of individual things. Remember, this is all in a Mosaic data set. So getting back to the raster functions, we'll go back to analysis. Raster functions, on-the-fly image processing, not creating a raster, stored in the project. There's one called minus. One image minus the other image. Heights of buildings and trees and stuff on the ground minus the ground gives us. We'll do our DSM minus our DEM. Click create the new layer. So now on the fly, I have a raster that gives me values basically from 0 to the tallest tree or building, which is 23 meters tall. Again, remember, Lidar into a last data set, into a Mosaic data set, which allows for lots of it to be done at the same time in a really quick way with the functions. All right, one more thing. We mentioned that some of the stuff that you could do is with raster functions, also some with geoprocessing tools, so actually creating outputs. And so geoprocessing tools that ship with the software that work with Lidar data kind of fall into 3 categories: data management, 3D analysis, or conversion. So if you see there in the data management, these are things like I just showed you, creating the last data set, adding files to the last data set. Let's say that I do one run of Lidar and I bring it into a last data set, and the next month later or the next year, they do another flyover, which is added into the same one. So some of these data management type tools. For analysis, these top couple deal with reclassifying it, right? So let's say I have a whole bunch of, or I should say I have a point cloud, and I realize that I have some kind of erroneous values. Well, I'm just going to reclassify them as noise. I'm going to show you guys this pretty cool one here for last point statistics. And you also have some conversions, right? So if you just wanted to create rasters right off the bat, convert your Lidar data to a raster. So what we're going to do now, let's assume that we have building footprint. Okay, so just square 2D polygons. And we want to take a look at these building heights in 3D. But where we got the building footprints, we don't actually have a height attribute. All right, so we'll do that, and then we'll, for kind of fun, we'll apply this thing called a rule package, which is something that you could create in another app that we have called City Engine to make the buildings look realistic, actually look like they have windows and doors and that sort of thing on them. All right, so now we're going to head to Miami. And again, we're in kind of a 3D scene. And if I click on any one of these building footprints, okay, got a bunch of attributes, we're going to assume that we don't have that one, right? So nothing about height in our attributes here. What we also have, though, is Lidar. And so if we kind of view this on the side, we're actually looking at building heights in downtown Miami. Of course, they have the height attributes. So there's a tool that we're going to use that's going to allow us to essentially overlay the building footprints with the Lidar height values and extract those Lidar height values into the building footprints. So let's hit into analysis. We're going to go to tools, and we're going to do last point statistics by area. So it requires two parameters, the input last data set, the input polygons, and we specify, hey, within each one of those polygons, find us the max Z value or the min Z value, or maybe the average, or even just the count of Lidar points within each one. So our last data set is going to be Miami. Input polygons will be our building footprints. We'll do the maximum Z value and click Run. So this is simply going to append a new attribute into our building footprint layer. And if we take a look at the attribute table now, using the Lidar data, we were able to add in a new attribute here that is the Zmax value for each one of those polygons. So now we have an attribute that we could use perhaps to extrude upwards in ArcGIS Pro. But rather than do that, let's do something kind of cool here. We'll make use of a city engine rule package, which is a nice way to do to visualize 3D data in ArcGIS Pro. So let's do features from city engine rules. Input features will be our building footprints. We'll point to a rule package. Say open. This is now going to create for us a 3D multi-patch feature class, so true 3D data. Number 2, and we'll click Run, and we'll see how we go. It only takes a second. Okay, run successfully, so now we'll draw them. Right. So as they start to come in here, again, this is all about starting off with something and using different tools and functions to create products from sort of the raw data. So we talked about spectral data, spectral imagery, multispectral imagery, and using bands to do things like land cover classification and image enhancement. Then we moved into Lidar, and we talked about several different ways to generate these real products that you can use in analysis or visualization and so on and so forth. So a couple of tools to go from a bunch of point clouds to pretty realistic looking buildings. And it's 2:38, so I think we need to start to wrap it up here. You want to flip over to you?
Sure.
So we could take a couple of questions. We might have to kind of move out into the hallway. But when we switch over here, make sure that if you get a chance to fill out the survey about it. So we appreciate that, and we learn from it, and we use your feedback as much as we can. So thanks for doing that.
Yeah, I mean, we have 5 more
We have
minutes.
5? Okay.
We can actually take a few questions.
Sure.
So, yeah, let's open it up. What's on your mind? What questions do you have?
Yeah, I was just wondering if you have any recommendations on any tutorials or lessons that are online that could help expand some of the image analysis?
For image analysis or for the Lidar stuff? Either? Esri training.
Esri training and just learn ArcGIS.com lesson on classification.
Sure, absolutely. So one place to go, you might want to try out the Esri training site. So if we go into the catalog here and go into Find Training, it breaks down into instructor-led, tutorial.
If you had a favorite or two offhand, I know about 4.
Okay, you do. Okay. There's a couple of good Lidar ones. So maybe after we can meet over here and I'll show them to you. Okay? And they're also on the Learn ArcGIS. So, well, let me just do a quick one here. Oh, sorry, I think we're on your screen.
Oh, sorry.
Okay. So if we explore our lessons, I know that there's a Lidar one here. So this is one extracting roof forms. So it works with Lidar data, and you do some pretty cool things with that. The Learn ArcGIS. In the Learn ArcGIS as well, you have, for example, this classify land cover, right? So that's going to be getting into imagery. I think there's another one in here that deals with image classification and using, like what Miriam talked about with the impervious surfaces, generating impervious surfaces. Yeah, calculating impervious surfaces from spectral imagery. So between the Esri training, the web courses, and the Learn ArcGIS, there's a lot of good stuff to get started. And YouTube videos.
Yep. Okay, in the back.
Well, it was one that I sort of, are you familiar with City Engine?
Question was, what was the City Engine rule that was used?
What was the City Engine rule that was used? So it's one that comes in, so if you have City Engine, one of the default projects is the Esri.lib. That's like a bunch of rules that come with City Engine. And I used that, but I had to tweak it a little bit. So it's not one that's out of the box. It's mostly out of the box, but I had to modify it a little bit to work for me.
I assume those rules require fields in the data set in order to make it.
That's what I had to do. So when I generated the Zmax attribute via the tool, I had to go into the City Engine rule and read through lots of lines of code and replace whatever the height attribute was there with my Zmax attribute. And if you want to talk more about that, I can talk about that. It does not. Pro does not come with City Engine rules, right?
No.
No.
You might want to check out the resources.arcgis.com site.
Where you could find rule packages. That's called a rule package, a .rpk file. So it's written in City Engine, but can be applied in Pro. Yeah.
Does Lidar work with imagery? Can it get through water?
That's a good question. I've heard of it, yes.
I mean, typically for bathymetry, we use sonar, right? That's what I know about, yeah.
That might be a good question for the 3D team at the product island down there. Yeah. I've not seen it, but I believe that I've heard of it. Any other questions?
All right.
Thank you for coming. Enjoy the rest of I'm sure that probably all of you are mostly taking off soon, but enjoy the rest of the conference and the party.
All right, and don't forget to fill out the surveys and give us good grades.